Okay, now let us talk about the next periodic property in the list, that is ionization potential. Ionization potential. Okay. Ionization potential, also known as ionization energy. Potential, also known as ionization energy. To understand this, let us have an example. Let us take the lithium atom. So if you draw the structure of lithium, the atomic number is 3. So the lithium atom will have 2 electrons in the first shell and 1 electron in the outermost shell. So this is how we are representing the 3 electrons of lithium in the orbital structure. So to attain the stable electronic configuration, that is the duplet in this case, I said you in the past classes that atoms of elements, they always want to acquire a stable electronic configuration that is similar to nearest noble gas. And if you see, the noble gases have either duplet or octet electronic configuration, that is their outermost shells either contain 2 electrons or 8 electrons. Apart from helium, all of the noble gases have octet electronic configuration. Okay. So lithium is going to lose this final electron, isn't it, to obtain the stable electronic configuration, to acquire the duplet structure. Okay, it is going to lose the final electron, and you cannot lose this electron. Lithium cannot lose this electron easily. Why? Because this electron is bounded with this nucleus. This nucleus is attracting this electron, and there is an energy undergoing it. So to overcome this energy, to break this bond, to break this attractive force, you need an energy. You need energy, isn't it? And what that energy is? That is ionization energy. That is ionization energy. So ionization energy is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. This is the definition which you have to learn, and I hope you understood the concept. So what is ionization energy? It is the amount of energy that is required to remove an electron from where? From the outermost shell of an atom, in simple words, or in technical words, isolated gaseous atom. You have to memorize this. Okay, it's very important. Now let us try to understand the unit. Okay, we have to learn the unit as well. What is the unit of ionization energy? The SI unit of ionization energy is kilojoule per mole. This is the SI unit, and you are familiar with this term SI unit, standard international standard units. Okay, so kilojoule per mole. What is mole? Kilojoule, joule is the unit of energy, and ionization energy is energy, so that's why kilojoule means kilo. Wherever you find kilo, that means 1000, so that's 1000 joule per mole. What is mole? You will not understand unless and until I will explain you chapter number 5, the mole concept, which is one of the most critical or complex ideas of chemistry. Why? Because it is not taught in the same way it has to be taught. It's very simple, it's very easy, but people make it very complex. The students make it very complex, and they think it to be very tough concept of chemistry, and it's very confusing as well. Okay, it's not confusing in reality, but people make it confusing. So the general unit of ionization energy is electron volts per atom. Electron volts per atom. Electron volts is also a unit of energy, and SI unit is kilojoule per mole. So you have to memorize both of these units. It may be asked in the objectives. Now let us try to understand what are the factors upon which ionization energy depends upon. What are the factors upon which the ionization energy depends?